let us begin today's class. And please wait till the end of the class, then I will share the link and everything. Don't worry. So the recording is started. I hope you should be able to see my slides. Please confirm when you are able to see the slides. Perfect. Thank you. So let's begin now. Sorry for this little delay today. And so we'll begin our second lecture. So in yesterday's lecture, we have seen that we can numerically integrate any function fx in the domain a to b, right? And for that, we have used two methods. What were those two methods? The first one was rectangular rule or rectangular method. Here in this method, the integrand fx, we approximated it with a constant function. Fx is equals to fxj star in the domain of xj minus 1 to xj plus 1. And the second rule which we studied was trapezoidal. In the trapezoidal, what did we do? We evaluated it by approximating it to a linear function. So geometrically, if this was the integrand fx, then in case of a rectangular rule, we found a midpoint x star and we made a rectangle from A to B. So this shaded region we found instead of the area under curve. Whereas in case of trapezoidal, if this was the function, then what did we do? We made a trapezium by joining these 2 points, and then we found this shaded region instead of the value of the function. So the next method, which I discussed yesterday, was our Simpson's 1/3 rule. In that I said that I will approximate fx by a quadratic function. What is the general quadratic function? The general quadratic function is ax square plus bx plus c. Any quadratic relationship can be represented in general by this form, and this geometrically is nothing but a parabola. Now, natural question is, why do you need, or rather, how many points do you need to have a parabolic relationship? Right? For line, you need 2 points. Like you remember line, if you want to draw a line, a specific fixed line, then you need minimum of 2 points. Okay. So if you have 2 points, you can determine a line. However, for determining a parabola, you need 3 points. The reason is simple, because the linear equation is, or the equation of line is a plus bx or y is equals to mx plus c. So there are 2 parameters, a, b here, mx plus c, m and c are the 2 parameters. Here for a quadratic function, you need to know the value of 3 parameters. And in order to evaluate 3 parameters, you need 3 values. Therefore, you need 3 points. Okay. So if we want to approximate a function, a quadratic function, then we need minimum of 3 points. All right. So first thing first, without getting into the details, what I will do is that I will try to give you an example, and then later on I will tell you that how that formula has come. So yesterday we wrote the formula for Simpson's 1 by 3, 1/3 rule. So this is the Simpson's 1/3 rule. This is the third method. Okay. In the Simpson's 1/3 rule, suppose if you have 3 points, I will tell you all the details. Okay. Have patience. But first you understand what I am telling here, mentioning here. Suppose you have 3 points, x0, x1, x2. Okay. And corresponding to x0, there is a point which is fx0. So this coordinate of this point will be x0 comma fx0. Now there is another point here. The coordinate of this point will be x1 comma fx1. Okay. And similarly, the coordinate of this third point, they will be x2 comma fx2. Okay. So these are the points. Now suppose the curve, function curve, which is passing through these points is like this. So this is our fx. Suppose this is our fx. Whereas I want a parabolic relationship between these 3 points. As I told you, I can generate a parabola passing through these 3 points. So I am drawing a parabola now. So this green color curve is a parabola P2x. So P2x is a parabola, matlab quadratic function. That will depend on the form of the parabola, but this is a quadratic function passing through this P2. 2 stands for second degree polynomial. Okay. P2x, P stands for polynomial, 2 stands for second degree, and polynomial in x. So it is a quadratic function or quadratic polynomial. So you can understand that what you are doing is that you are basically approximating the function values by a quadratic polynomial. However, they may or may not match all the values of the function fx. For example, in this case, red color and green color curve are different curves. But when we have to integrate from x0 to x2, the integral fx dx, we approximately replace this function fx by the polynomial p2x. That means red color function is in. So let me replace it by red color function, and that we are replacing red color function. We are replacing by the green color polynomial curve. So p2x I will replace by p2x dx, and then eventually you will see that this integration will become, as I told you yesterday, we will represent here onwards fx0 as f0, fx1 as f1, etc., etc. It means fxj as fj. So this is the representation we will use. Please note it very carefully that here onwards the meaning of the subscript will be what I have highlighted here. All right. So my Simpson's 1/3 formula, after this replacement, I will show you explicitly in some time. This will become h by 3. What is h here? H is the width. As I told you earlier, these are equidistant points. So this is the h by 3. F1 plus 4f3, 4f1 plus 4f2. Sorry, there is no f1 and f2. f0 plus 4f1 plus f2. That means f0, the value here, plus 4 times f1 plus f2. If I add up these values, then I will get the value of the integral fx ds, approx value. This is approx value, and this is referred as Simpson's formula, x0 to x2. Notice carefully the limits here, x0 to x2 fx dx. So this is our Simpson's 1/3 formula. Okay, so this is our Simpson's 1/3 formula. Now here there are 3 points, whereas in general when you have interval a to b, if you have to evaluate the integral in the interval a to b, you recall that क्या होता था a to b में, हम लोग n पार्टीशन करते थे, करेक्ट? x0 is equals to a, this is x1, x2, x3 dot 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 xn minus 1 and xn is equals to b. तो हमारे वो सारे के सारे पार्टीशन कैसे होते थे, a प्लस jh, जहां पे j की वैल्यू 0 से n के बीच में होती थी. सो टोटल n+1 पॉइंट्स के पार्टीशंस होते थे टोटल. सो if we have to make n+1 partitions, then how will our Simpson's 1/3 formula will look like? So for that, corresponding value f0, f1, f2, f3, assume that here there is f4, like that, then dot dot dot, suppose here is fxn and here is like that. So there will be some function which will be passing through these points. So this is our fx, assume that this is our fx. Now we have to draw polynomials in order to find out the now we have to draw the polynomial curve. So blue color, I am drawing the polynomial P2. So approximating a parabolic curve here to here. So you see here to here, and then dot 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 another parabolic curve. If you notice carefully, in order to draw a parabola, I need 3 points. So first parabola is drawn with x0, x1, x2. Second parabola is drawn with x1, x2, x2, x3, x4. So notice carefully that you will need even number of points in this case. So it is very important fact. जो n हमारा है वो हमेशा even होना चाहिए. n is equals to 2m, because otherwise you won't be able to define the parabolas, right? So this is one P2, this is another P2 which you will define. So every sub 2 point sub interval you have to define the parabolas. Okay, so for that you will need the partitions to be an even number. You can easily see that from the example also. x0 to x2, first parabola is defined, then x2 to x4, second parabola is defined, then x4, x5, x6, third parabola will be defined, and then so on and so forth. So if you want to define a parabola covering all the points, then xn must be an even number. Okay, so in order to apply the formula, Simpson's 1/3 formula, my n must be even number. Now on each of these, okay, so the interval from integration from a to b of any function fx dx will be equals to the integration from x0 to x2. Let me write it clearly for you. This will be equals to the integration, first one, from x0 to x2 p2x dx approximately, then plus integration from x2 to x4 will be equals to p2x dx. Notice that these p2s will be different because they are passing through different points, so their formulas will be different. You can call them as p21, p22, like that, and plus dot 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 last one, x n minus 2 टू xn, आपको देखो तो 2 पॉइंट्स का डिफरेंस आ रहा है ना। सो xn से xn माइनस 2 तक, xn माइनस 1 एंड xn माइनस 2, वहां पे p2n कर लेते हैं, जो भी आएगा उसका ऑफ x dx। तो ऐसे आप हर एक फंक्शन का, हर एक इंटीग्रल का वैल्यू निकालेंगे। फर्स्ट इंटीग्रल हियर, this integral we have already seen in this previous slide. p2x, when I replace, what does the value comes? f0, 4f1, f2. So I'll replace this h by 3, f0 plus 4f1 plus f2, f0 plus 4f1 plus f2। सेकेंड वाला इंटीग्रल ऐसे निकालेंगे हम लोग, h by 3, ये क्या हो जाएगा, ये देखो f2 plus 4f3 plus f4, f2 plus 4f3 plus f4। ऐसे करते हुए आप डॉट 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 करेंगे और लास्ट वाला देखो तो कैसे लिखेंगे आप, फिर से h by 3, लास्ट वाला ये n-2 है, fn-2, fn-1, fn-2 plus 4fn-1 plus fn. This will become h by 3, finally f0, ध्यान से देखो, प्लस 4 कॉमन हो जाएगा यहाँ पे, f1, f3, ऐसे करते हुए fn-1 तक, ऑड वाले सारे f1 प्लस f3 प्लस f5 प्लस डॉट 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 प्लस fn-1, सारे ऑड टर्म यहाँ पे आ जाएंगे। प्लस देखो f2 क्या हो रहा है, एक बार यहाँ पे आया, एक बार यहाँ पे, टोटल 2 बार f2 आया है, तो f2 कितना हो जाएगा, 2f2। इसी तरह से f4 यहाँ पे आया एक बार और एक बार अगले वाले ब्रैकेट में आएगा, प्लस f4। सो जो इवेंट टर्म्स हैं वो सब 2 बार आएंगे, 2 टाइम्स, डॉट डॉट डॉट, कहां तक, लास्ट वाले इस तक, fn-2 तक, और प्लस जो लास्ट वाला टर्म है वो आखिरी में सिंगल बार आ रहा है, तो fn हो जाएगा। So this will become our formula for a to b fx dx when we are making partition. And how many partitions are we making? N is equals to 2m. Always remember that n is equals to, here n is equals to 2m, here n is equals to 2m. This we have to always keep in mind when we are evaluating. Now I will give you one example before moving forward. So the example is this one. Integrate this integral I is equals to 0 to 1 e raised to power minus x square dx. सपोज हमें क्या करना है, इस वाले इंटीग्रल की वैल्यू निकालनी है कि इसकी वैल्यू क्या होगी। ओके, सो फर्स्ट थिंग फर्स्ट, सबसे पहले तो यहाँ पे क्या करना है, हमें पार्टीशन करना है। एज आई टोल्ड यू अर्लियर, फर्स्ट थिंग फर्स्ट, यू हैव टू डू द पार्टीशन। पार्टीशन के लिए कितना है, नंबर ऑफ पॉइंट्स चूज करने हैं, n। एज आई टोल्ड यू, n मस्ट बी एन इवन नंबर, तो एज्यूम दैट आई एम चूजिंग n इज इक्वल्स टू 10। सपोज करो कि मैंने n को 10 ले रखा हुआ है। इफ n इज इक्वल्स टू 10, a इज इक्वल्स टू हियर 0, b इज इक्वल्स टू 1, सो xj अकॉर्डिंग टू द फार्मूला क्या हो जाएगा, 0 प्लस jh, so this will become jh for j lying between 0 to 10, where h का वैल्यू कितना है, 1 minus 0 divided by 10, 1 by 10, that is 0.1. Can you understand this, all this calculation? n 10 सेलेक्ट किया हमने, a 0 गिवन है, b is equals to 1 गिवन है, तो xj का वैल्यू फार्मूला हमारा होता है a plus jh, जहां पे j 0 से 10 के बीच में है, और h का जो फार्मूला होता है वो b minus a by n होता है, वहां से हमारा ये निकल के आ गया। ठीक है, so all these values are now known to me. Now what I will do is that I will make the tabulated value of this fx, because I need, in order to apply the Simpson's 1/3 formula, I need f1, f2, etc. n is even, this you must notice. Okay, तो यहाँ पे हम सबसे पहले टेबलेटेड वैल्यू में क्या कर लेंगे, j हम मेंशन कर रहे हैं, सो दैट कि वो f0, f1 etc. हम निकाल लेंगे यहाँ से। j इज इक्वल्स टू क्या हो जाएगा, 0, 1, 2 3, जे की वैल्यूज यहां से आप समझ सकते हो, 4 5 6 7 8 9 और 10. Corresponding to each j, there is a value of xj, and that value of xj is given by the formula jh. Xj is equals to jh. Keep on substituting the value of j and h successively. You will get j is equals to 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1.0, not 0.10. okay, 1.0. हमें क्या वैल्यू निकालनी है? fx की वैल्यू जो निकालनी, वो कौन सी निकालनी है? e raised to power minus of xj स्क्वायर, e raised to power minus of xj स्क्वायर. तो क्या कर लेते हैं, एक xj स्क्वायर वाला कॉलम और एक्स्ट्रा डाल देते हैं यहाँ पे. तो 0 हो गया, 0.01, 0.04, 0.09, 0.16, 0.25, 0.36, okay, 0.49, 0.64, 0.81, and the last one is 1.0. 1 का स्क्वायर 1 ही रहेगा, तो उसमें कोई चेंज नहीं आएगा. सो फर्स्ट वैल्यू e raised to power 0 minus 0 in fact, so that will be your value 1. This will be 1. E raised to power 0, that value will be 1. Second value, use the calculator, e raised to power minus of 0.01. e raised to power minus of 0.01. इसका जब आप वैल्यू निकालोगे तो क्या आ जाएगा? 0. यूज द कैलकुलेटर, 0.990050. मैंने 6 डेसिमल पॉइंट तक लिया हुआ है, आप चाहो तो 3 तक ले सकते हो, 4 तक ले सकते हो, दैट विल डिपेंड ऑन व्हाट यू आर सिलेक्टिंग. ओके, सेकेंड वैल्यू इसी तरह से निकालोगे, e raised to power माइनस ऑफ 0.04, वो वैल्यू कितना निकल के आएगा? 0.960789. लास्ट क्लास में भी हमने कुछ वैल्यूज निकाली थी, इफ यू रिकॉल. इसका वैल्यू 0. सो आई एम राइटिंग ऑल द वैल्यूज. 0.913931. I have evaluated all the values already. That's why I am filling all there. So it is not taking much of the time. 0.16 corresponding to 0.16, you will get 0.852144. Corresponding to 0.25, you will get 0.778801. Then corresponding to 36, you will get 0.697676. The next value corresponding to 0.49, you will get as 0.61. You should be very careful. 2626. Here I will make some comment also. So let me put a space for comment. 0.52. The next value is 0.52. 7292, 7292. Second last value 0.444, 858, 858. And the last value is e raised to power minus 1. Yesterday we have calculated this value. So this value turns out to be 0.367879. Yesterday we have chosen fewer partitions. Now we have chosen multiple partitions. So this first value is actually our f0 because it is f at x0. Second value is f1. This is f2. This is f3. This is f4. This is f5. This is f6. This is f7. This is f8. This is f9 and this is f10. तो ये तो हमारी सारी वैल्यूज हो गई, ठीक है ना. ये सारी वैल्यूज हमने निकाल ली. अब हमें क्या करना है? वी हैव टू अप्लाई सिम्पसन्स 1/3 rule. Okay, so I'll make this slide little bigger so that we can see these values, and we'll apply the Simpson's 1/3 rule. This rule, ये जो यहाँ पे हमने लिखा हुआ है, so you will use this formula. So I will write this formula. So integration from 0 to 1 e raised to power minus x square dx, ये वैल्यू हो जाएगी अकॉर्डिंग टू दैट फॉर्मूला h/3 f0 प्लस 4 टाइम्स f1, ऑड वाले सारे आ जाएंगे, f1 f3 f5। देखो कहां तक वैल्यूज आ रही थी वहां पे, fn-1, n आपका क्या है 10, तो इसका मतलब यहाँ पे जो वैल्यू आएगी वो कहां तक आएगी 10-1, दैट इज 9। उसी तरह से ये कहां तक वैल्यू आएगी 10-2, दैट इज 8, और लास्ट वैल्यू आएगी f10। बहुत ध्यान रखना है ये वाली चीजों का, अदरवाइज मिस्टेक हो जाएगी। f5 f7 f9 तक जाकर के ये बंद हो जाएगा, 2 टाइम्स f2, सारे इवन आएंगे यहाँ पे, f4 f6 f8 पे रुकना है यहाँ पे, और लास्ट वैल्यू f10 आपकी अकेले रहेगी। इस वाली स्लाइड से आपको सारी वैल्यूज देखो तो दिख रही हैं, राइट? All the values you can see from here, correct? So just substitute them. So substitute करो, आप चेक करोगे 0.1 h का वैल्यू है, इसका वैल्यू 3 है, ओके। f0 का वैल्यू 1 है, प्लस 4 टाइम्स f1 का वैल्यू 0.990050 प्लस f3 प्लस f5, ऐसे करते हुए सारे f9 तक आप वैल्यू रखोगे, 0.444858। इनफैक्ट ये सब ऐसे रखने की जरूरत नहीं है, यू हैव टू यूज द कैलकुलेटर, सो यू यूज द कैलकुलेटर एंड कैलकुलेट ऑल द वैल्यूज, प्लस 2 टाइम्स आप ऐसे f2 का वैल्यू रखोगे 0.960789 प्लस डॉट डॉट डॉट, आपको f8 तक वैल्यू रखना है, f8 इज 0.527292 प्लस लास्ट वैल्यू आपको f10 का रखना है 0.367879, okay, and then you close the bracket. If you have calculator, if you have a calculator, you check the value. This value should turn out to be 0.1/3, 1 plus 4 times 3.7 40266 plus 2 times 3.03 7901 plus 0.367879. This is the value you should get, and the final value is 0.746825. This is the answer which you get, okay? So this is mere substitution, so calculating the values and then evaluating the values, okay? As I mentioned, I will give you 2 comments. If there are any questions, let me see at the moment. I'll try to address them. So how x is equals to 2n, not x is equals to 2n. N is equals to 2m. So one argument is that you can understand it from the number of points you need in order to fix a parabola is 3, right? And you are starting with 0. So how many points will you need if you want to fix a parabola, right? So obviously you will need an odd number of points. I mean, not exactly the odd in the sense of, so you check the points from here. I mean, how should I explain this one? Well, you check the number of points which you are doing here. Okay, so for fixing this parabola you need 3 points, then for fixing this parabola you again need 3 points. Okay, so and 1 point is overlapping. So basically how many points do you need in order to fix here? 1, 2, 3, 4 and 5. So every time if you are fixing a parabola, you need odd number of points in total. Can you understand that? You need odd number of points in total, right? Because every time what will happen, 2 new points you will need in order to fix the parabola wherever you stop. For example, if I am fixing the parabola of the points x0, x1, x2. So I will need these 3 points. Then next parabola, if I want to fix, I have to start from x2, but then 2 additional point I will need, right? So 3 plus even number of points. So every time I will proceed, I will need even number of points. So that will make total number of points as odd points. In order to ensure that the total number of points are odd points, what I am doing is that I am making even number of partitions. So total even number of partitions will make the number of points as even plus 1, which will make it odd number of points. I hope that clears. Why we need xj? अरे भाई xj पे ही तो सारा कुछ इवैल्यूएशन करना है, वहीं पे तो आपका डेटा है सारा कुछ. xj's are the point where you have all the data, right? Could you please show me the formula slide again? Yes, of course I can show you the formula. Yes, that's the formula slide which I'm showing right now. Okay. Yes, absolutely. You have to use the calculator everywhere. Okay. Font size of the pointer. Oh, basically I'm using stylus, and that I have to check. Let me see if I can use the font size, because otherwise it depends on the thickness of the the marker which I am using. So this stylus is giving you that pointer only. And which is more accurate in both. Naturally, Simpson's 1/3 is more accurate because you have used फार्मूला का डेरिवेशन अभी किया नहीं है तो समझ में नहीं आएगा. लेट मी जस्ट give it to you. So Simpson's 1/3 you have used a quadratic polynomial. That means better than the linear. You are trying to make it better than the linear. However, the trapezoidal may also work sometimes if you make more number of partitions. I made this argument yesterday also. If you make more number of partitions, the trapezoidal may work better. But if you are using the similar number of partitions, then Simpson's 1/3 will work better. If you, yes, that's what I'm telling. If you take more number of partitions, the trapezoidal will be very much closer to the less number of partitions of the Simpsons. But in general, the error of Simpson is lesser than the error, because there you are approximating a function by quadratic nonlinearity. General nonlinearity may be very huge, right? Naturally, if you want to understand anything, you need to either remember it or understand it so that you can reproduce it when you need it. So that is how the understanding works, right? For anything, if we need to understand, we have to understand how the derivations work. Perfect. So I don't think that there is anything relevant, any relevant questions from my slides. So I will move forward and I will move to the comment. Okay. So the 2 comments which I want to make here. So I'll make 2 comments. This one is very important. Comment 1. If you see, I have taken here 6 decimal places, right? You can take 10 decimal places. Nobody knows where to stop, right? Accuracy is there, right? So you take more decimal places, you will be accurate. However, it is expected, I'm using the word expected to use 3 decimal places minimum. Okay, 3 decimal places. Now, this is very challenging while answering the question. So in exam or in quiz or anywhere, in exam, it may happen that my answer and your answer might be differing at the third point or fourth point. So what should be your answer? So if the answer, so you have to answer the closest one. Okay, closest one. So suppose that the answer in this case, for example, in this case the answer is, my answer is 746825, and this is one of the options, whereas your answer comes as 74, let us say 46 something. Okay, so the 7446, that will be the correct answer. If it is optional question, then that will be the correct answer. So the, even if you don't match exactly, whatever is the closest number to that one, that should be considered as the correct answer. Okay, so the closest one should be the correct answer, but closest does not mean that 65 is the closest one. That way it won't work. Decimal places, so 746, if my answer is 746, then your answer should be at least 74 plus something, right? So 740 to 749, that much closeness I will expect. Okay, so that is how you should be able to answer, because depending on the device, depending on the accuracy, depending on the number of decimal points one chooses, the answer varies. For example, if you take 3 decimal points, you will figure out that the answer will vary. I have chosen 6 decimal points. If you choose 3 decimal points, the answer will vary. Okay, so that's very important comment which I am giving here, which you have to note, that how to understand the answer and how to answer them during the examination. Okay, I hope that point is clear. Okay. Yes, that's naturally you can use y is equals to x, because they, anyway, a first degree polynomial will be plotted. In that case, the quadratic term will be 0. I mean, the coefficient of x square will be 0. So you can plot it. There will be no problem with that one. All right. So whenever you are evaluating, you have to evaluate. The second important comment is that comment. This is comment number 1, and this is comment number 2. Comment number 2 is that in some question we might not even have this fx. So data points will be given, as I mentioned in the very beginning. Data points will be given. When the data points are given, you actually don't know what is the function. And in that case, you identify the data as x0, x1, x2, xn, as f0, f1, f2, fn. If this number of these points, of course, if n is equals to 2m, then you can easily apply your Simpson's 1/3 formula without actually knowing the function. So suppose I give you only this data point, nothing. I give you x0 is equals to 0 and the value of the function f0 as 1, and I ask you to find out the Simpson's find out the integral using Simpson's 1/3 rule. You don't need e raised to power minus x square. You directly use the formula and you will get the integration, and you will say that this is the way you can get the integration. Okay, so the point here is that if the data points are given, not the function is given, then also we can apply simply this Simpson's 1/3 formula and get the value of numerical integration. All right, so that is one point of view to look at it. I will quickly give you an example, and I will not give all the details. Maybe you can fill in the details. So take this an example. Suppose I give you x is equals to x values, like its tabulated value, as I told you. So this is x0, 4.0, 4.2, 4.4, 4.6, 4.8, 5.0, 5.2. You can see that the data are equi-spaced, and the fx value I give you is 1.3863, 4 decimal values, 1.4351, 1.4816, 1.5261, 1.568, 1.86, 1.6094, and 1.6487. And I ask you, corresponding to this function fx, I ask you to find out the integral from 4.0 to 5.2. This is 5.2. Okay, 5.2. I ask you to find out this integral. Then what will you do? You have equidistance formula. You will use the Simpson's 1/3 rule. Simpson's 1/3 rule will say what? H by 3. What is H here? H, one can easily see. H is 0.2. The difference between any two subsequent points. H is equals to 0.2. Okay. So you can apply the Simpson's 1/3 formula. What is Simpson's 1/3 formula? H by 3. 0.2 by 3. Then F0. So F0 will become, this is your X0. That is how you have to identify X0, X1, X2, X3, X4, X5, X6. Okay, you can easily understand, correct? So here n is equals to 6. That means you can apply this formula, and this will become F0, F1, F2, F3, F4, F5, and F6. So what will be the value here? F0. F0 plus 4. Formula. Remember formula. F1, F3, F5, F7 is not there. Okay. Plus 2 times even F2, 4, not F6. Not F6. Okay. Because F6 is the last fellow. Plus F6. Substitute all the values. Get the answer. Okay. Whatever the values. This is left as homework. Okay. Left as homework. Okay. Once you have done the values, then you find out that these values which I have given you, they are coming from the log functions. These are the value of log x. So the first value is log 4, second value is log 4.2, third value is log 4.4, and then so on and so forth. So you can easily see what is the integral. You can easily see using the formula what is the integral if you know the formula for integral 4.2 log x dx, and see whether your value matches with that value or not. Okay. So this also you can verify. You can verify. So this is left as homework for you, and then you try and do that one. All right. So n is equals to 2m. I explained that point, right? Not m is the number of points. Small n is the number of partitions or number of points. आपके जो n है उसके रेफरेंस में है. 2m का मतलब क्या हुआ? उसको उतने बार आपको जो है जो पार्टीशनिंग करनी है वो इवन नंबर में करनी है. जो हमने उदाहरण दिया ना, एग्जांपल दिया हुआ है. यहाँ पर भी देखो हमने पार्टीशनिंग कितने पॉइंट में करी थी. इस वाले क्वेश्चन में 10 हिस्से में करी. 10 इज एन इवन नंबर. यहाँ पर भी पार्टीशनिंग कितनी हुई इवेंचुअली जो हमें डेटा पॉइंट्स मिल रहे हैं उसमें पार्टीशंस कितने हैं? 4 to 4.2, 1, 4.2 to this is 2, this is 3, this is 4, this is 5, and this is 6. So total number of partitions are 6. तो नंबर ऑफ पार्टीशंस जो हमारे हैं वो इवन होने चाहिए. ओके. 2m का मतलब होता है इवन. 2m कभी भी ऑड नहीं हो सकता है, इसलिए हम ले रहे हैं वहां पे. तो 2m मस्ट बी एन इवन नंबर बिकॉज वी वांट टू फिट इट इनटू ए क्वाड्रेटिक फॉर्मूला. तो इसलिए हमें वो करना पड़ता है. अगर हमको क्वाड्रेटिक में फिट करना है देन वी मस्ट चूज n to be an even number. Otherwise वो हमारा क्वाड्रेटिक में फिट नहीं होगा. So this is Simpson's 1/3 rule. Now, as I promised, I will get into the derivation of Simpson's 1/3 formula. Okay. तो Simpson's 1/3 formula का derivation करने के लिए हमें एक क्वाड्रेटिक पॉलिनोमियल की जरूरत होगी, और वो क्वाड्रेटिक पॉलिनोमियल अभी हम ऐसे ही लिख देंगे. आपको थोड़ा सा वो चीज याद रखनी होगी कि मैं उसका रेफरेंस बता दूंगा, बट यू हैव टू कंसीडर दैट विदाउट गेटिंग इनटू डिटेल्स. ओके. डेरिवेशन ऑफ Simpson's 1/3 rule. So as I told you, in case of Simpson's 1/3 rule, I have to integrate from A to B. So instead of integrating from A to B, what I will do is that if I am able to show this part, this is the part which I will show. That means this part integration. So if I'm able to show that this value equals to this value, then the rest of the values I can find, right? So I don't need to explain that rest of the things. So my proof will be for this part only. All right. So we will consider that the value of the function from x0 to x2. This is the point x1, x0, x1, x2. Suppose that this is the function and we approximate it by a quadratic polynomial P2, which is this. So this is your P2 x parabola, and this black color function is your original function fx. Okay. The value of these points are given as x0, f0, x1, f1, x2, f2. Okay. Now, the first thing we do is that we want to derive a quadratic function. A quadratic function. What is a quadratic function? A function of the form ax square plus bx plus c. But if we derive the quadratic function in this form, you will find that the integration later on will become very complicated. So since the integration becomes very complicated, so we do not use this quadratic formula. Rather, we use what is referred as Lagrange quadratic polynomial. So Lagrange gave a quadratic polynomial. Obviously, 3 points, it is passing through 3 points. So a quadratic polynomial passing through 3 points, this formula was given by Lagrange, P2x. And the formula for that is x minus x1, x minus x2 over x0 minus x1, x0 minus x2. If you notice, it is a quadratic because linear multiplied, and here the value is f0. f0 means f at x0 plus x minus x0, x minus x2 divided by x1 minus x0 and x1 minus x2, f1 plus the last term x minus x0, x minus x1, x2 minus x0 and x2 minus x1, f2. If you notice carefully, these factors, numerator and denominator, are same, except that x is replaced by x0 in the first term, x is replaced by x1 in the second term, x is replaced by x2 in the third term, and here the f value is replaced by fx0, fx1, fx2 respectively. So then you will get a quadratic formula, quadratic function. So then you will get a quadratic polynomial, which will look like of this form, but this is the called Lagrange's quadratic polynomial. So we'll use this. So I assume that you will you can find out details if needed, if you want to learn that how this polynomial is derived, but we will not get into that details. Okay. So this is a quadratic, as I mentioned, this is a quadratic polynomial. Now, what do I need? I need to find out the integration. Okay, I need to find out, let me write it here. I need to find out the integration from x0 to x2 of fx dx. which I have approximated by x0 to x2, and instead of fx, I will write now p2x dx. Okay. Later on, what I will do is that I will change the variable, because p2x dx, as you can see, the formula of p2x is very complicated. If I substitute the values here of p2x in the integration, it becomes very difficult for me to integrate that integration. So what do? I use a transformation to make my life simpler. It is my choice. Therefore, I am choosing a new variable s is equals to x minus x1 divided by h. What is h here? Since these points are equidistant, this value is referred as h. X minus x1 by h. Notice this is my choice. Okay. So I am choosing. Why I am choosing? Because I want to integrate. Otherwise, I won't be able to integrate. So I am choosing this s is equals to x minus x1 by h. Moreover, here x1 and h are fixed. That means the variable is s. So this will mean that x is equals to s plus, this will mean that x is equals to x1 plus sh, or this will also mean that x minus x1 is equals to sh, and this will also mean that dx is equals to h ds. Okay, so that I can change the transform the variable, the integral variable. This is the reason why I am choosing it in this manner, because I want to change the integration. Okay, I want to integrate. What do I want to integrate? I want to integrate this p2. So now I will replace this p2x into new form, some new p2s, and this dx I will replace by h ds. The limits will change accordingly. Okay, so we have to see what will be the limits. That can be seen very easily from here. What will be the limits? So if this is the value, then x minus what I want to find out here, x0. Yeah, so x0 is equals to what? X0 is equals to, if you see x0 with reference to x1, what is x0? X0 plus h is equals to x1, correct? X0 plus h is equals to x1. Therefore, x0 is equals to x1 minus h. Okay, x0 is equals to x1 minus h. One second. X0 is equals to x1 minus h, correct? Now, when x is equals to x0, what will be the value of? So this will imply s at x0 will be equals to x0 minus x1 by h, correct? Or in other words, you can also say that when x is equals to x0, so from here you can easily see x0 minus x1 is equals to, I think this will be a little bit more difficult to understand. We'll make it directly from inference from here itself. So when x is equals to x0, this will imply s is equals to x0 minus x1 divided by h. From here you can see x0 minus x1 is equals to minus h. Therefore, this value is minus 1. This will be far more easier for you to understand. Similarly, when x is equals to x2, this will imply s is equals to x2 minus x1 by h, x2 minus x1. Now again, you can easily see from here, x2 is equals to nothing but x1 plus h. x2 is equals to x1 plus h. Therefore, this value will be h by h, and therefore s is equals to minus s is equal to plus 1. So the integral, this integral will be converted to s is equals to minus 1, s is equals to minus 1 to s is equals to plus 1, s is equals to minus 1 to s is equals to plus 1. Okay. So now only thing I need to do is that I need to replace this p2x into p2s. ठीक है ना? So I need to replace this p2x into p2s. Okay. So wherever there is x, I will replace this x by this formula, x is equal to x1 plus sh. But it may look little bit complicated. Therefore, what I will do is that I will solve all these values, x minus x1, x minus x2, x minus x0. All the three values I will figure out. So first value is x minus x1, which is already given by sh. Second value is x minus x0, which I can write as x minus x1 minus h equals to x minus x1 plus h, and x minus x1 is sh. So this will become s plus 1h. Third value is x minus x2, which I will write as x minus x2. In place of x2, I will write x1 plus h. This again I will write x minus x1 minus h, which I will write sh minus h. So it will become s minus 1h. Okay. So now this p2s replacing x by s. Let me make it a little bigger for you. This is your p2x. So substitute the values of x minus x0, x minus x2, etc., etc. So first term in p2x is x minus x1. What is x minus x1? sh multiplied by. Second term is x minus x2. I'm not sure if you are able to see this one. Let me show you once again. X minus x1, x minus x2 divided by x0 minus x1, x0 minus x2. X minus x1 is sh, x minus x2 is s minus 1h, s minus 1h divided by x0 minus x1. Here you can see that I have already written x0 minus x1 is minus h, and x0 minus x2. In fact, you can see that these are nothing but the distances. So this distance x0 minus x2, this is 2h distance, total distance is 2h. If you subtract x0 minus x2, it will be negative of 2h. So eventually you will get divided by minus h into minus 2h. And then the final value f0 plus x minus x0. X minus x0 is s plus 1h. X minus x2. X minus x2 is s minus 1h divided by x1 minus x0, that is h, and x1 minus x2, that is minus h. F1 plus, similarly you write the third term. I'm writing it directly for you. Check that later on. S plus 1h into sh divided by 2h into h f2. Okay. Simply the whole term is converted into an expression in s now. 1 by 2 s into s minus 1 f0 minus s square minus 1 of f1 plus 1 by 2 s into s plus 1 of f2. This p2s red color term, substitute in the p2s red color term here. Eventually what you will get is this integration from minus 1 to 1. P2s is 1 by 2. H is common actually. So h you can write outside. 1 by 2 s into s minus 1. S into s minus 1. Everybody should be aware of the integrations. F0 is constant, minus s square minus 1 f1 plus 1 by 2 s into s plus 1 f2 ds. Once you do the final integration, this is with respect to s. So final integration with respect to s, once you do, then you will get this term, what I'm writing now, h by 3 f0 plus 4f1 plus f2. And this is what the integration from x0 to x2 fx dx as Simpson's 1/3 rule. So this is what the formula of Simpson's 1/3 rule, Simpson's 1/3 rule, which you have got. So this is the formula of Simpson's 1/3 rule, which you have got by finding out the integration. Now we have written a polynomial function or quadratic function, and from that polynomial function or quadratic function, we have got the Simpson's 1/3 rule for the interval. कहाँ पे हमने फाइंड किया इस वाले को, ध्यान से देखो, x0 से x2 के बीच में, मतलब हम लोगों ने ये वाला इंटीग्रल अभी फाइंड किया, x0 से x2. सिमिलरली x2 से x4 वाला करोगे तो क्या होगा, h by 3 f2 plus 4f3 plus f4 मिलेगा, एंड देन सो ऑन सो फोर्थ करते हुए चले जाओगे, आखिरी में आपको लास्ट वाला पैराबोला मिलेगा. सो टोटल जब आप सम कर दोगे सारे पैराबोलास का एरिया, तो देन यू विल गेट द टोटल एरिया ऑफ द फंक्शन from A to B. So then you will get this formula which you have to use in general. Okay, तो ये आपको हमेशा यूज करना है जनरली, और इसमें n is equals to 2m लेना है. किसी को ये डाउट हो तो अभी पूछिए, मैं उसको आर्गुमेंट को रिपीट कर दूंगा. h is equals to b minus a by n. Correct, h is equals to b minus a by n. लास्ट स्लाइड फार्मूला रिपीट, लास्ट स्लाइड कौन सा है, ये वाला. तो सी, हम लास्ट का मैं पूरा ही रिपीट कर दे रहा हूं. सबसे पहले हमने क्या किया, लैग्रेंज का क्वाड्रेटिक पॉलिनोमियल 3 पॉइंट से जाता हुआ वो निकाला. ये फार्मूला जो है मैंने रख दिया, आप एज्यूम करके चलिए कि ये वाला फार्मूला इसका मैंने आपको डेरिवेशन नहीं पढ़ाया है, ठीक है ना. किसी और क्लास में अगर कुछ वक्त मिलेगा तो मैं इसका डेरिवेशन पढ़ा दूंगा. इट्स नॉट वेरी डिफिकल्ट. ये वाला जो डेरिवेशन हमने लिखा था ना, ax² + bx + c, ये इसी से आता है, बट मान के चलो कि ये ऐसे करके फार्मूला आ गया. अगर 3 पॉइंट आपको दिए, x0 f0 x1 f1 और x2 f2. अब हमें क्या है कि इसको इंटीग्रेट करना है p2x को. आपको दिखाया था हमको कि fx approximately equals to p2x, बट अगर p2x हम एज इट इज इसको यहाँ पे रख देंगे, देन द इंटीग्रेशन विल बिकम वेरी डिफिकल्ट. इवेंचुअली वो वही आएगा, बट इट विल बी वेरी डिफिकल्ट टू इंटीग्रेट. सो इन ऑर्डर टू रिड्यूस द लेबर फॉर इंटीग्रेशन, हमने क्या किया, एक चेंज ऑफ वेरिएबल यूज कर लिया. s को x minus x1 by h लिख दिया. और जब x minus x1 by h लिखा x को, तो x minus x2 क्या है उसका वैल्यू रखना पड़ेगा हमें, x minus x0 क्या है उसका वैल्यू रखना पड़ेगा. तो वो वैल्यू हमने यहाँ से कैलकुलेट कर ली कि x minus x0 का वैल्यू s plus 1h है, x minus x2 का वैल्यू s minus 1h है, और x minus x1 का वैल्यू sh है. इनका सबका वैल्यू उठा करके रखते चले गए, तो हमें p2 का वैल्यू s के फॉर्म में आ गया. p2 जो x का फंक्शन था वो अब s का फंक्शन बन गया. अब जो p2 जो s का फंक्शन बन गया, ये वाला फंक्शन रेड कलर में जो लिखा हुआ है, इसको हमने क्या किया, यहाँ पे x से s वेरिएबल में ट्रांसफर कर दिया. तो s से x, जब x से s वैल्यू में आप ट्रांसफर करोगे तो x की जो लिमिट्स है वो भी तो बदल जाएंगी. तो लिमिट्स भी बदल गई, तो लिमिट्स भी हम लोगों ने बदल दिया. जो लिमिट बदलने के बाद में ये जो टोटल है p2s, इसकी वैल्यू यहाँ पे सब्स्टिट्यूट कर दी और इसको इंटीग्रेट कर दिया. इंटीग्रेशन देखो मैंने नहीं किया हुआ है, पर फिर भी मैं तुम्हें थोड़ा सा यहाँ पे हिंट दे सकता हूँ. इंटीग्रेशन ये क्या है, -1 से 1. तो इसको आप क्या लिख सकते हो, इंटीग्रेशन जो है -1 से 1 वाले को, इसको देखो यहाँ पे आप लिख सकते हो इक्वल्स टू h, जो इवन है वो तो 2 टाइम्स हो जाएगा, 0 to 1 2 टाइम्स हो जाएगा. तो यहाँ पे पहला फंक्शन क्या है, s² तो इवन फंक्शन है, तो s² by 2 f0, इसका तो इवन है तो इसलिए इसका 2 टाइम हो जाएगा इंटीग्रल. माइनस s by 2, s ऑड फंक्शन है s का, तो उसका इंटीग्रल 0 हो जाएगा. फिर माइनस s² f1, तो s² f1 का जो इंटीग्रेशन है वो s² f1 बना रहेगा, क्योंकि वो इवन फंक्शन है, 2 टाइम्स हो गया. -1 वो माइनस माइनस प्लस हो जाएगा, प्लस f1 वो भी इवन रहेगा बिकॉज 1 इज इवन फंक्शन. अगला फंक्शन क्या है, हाफ s प्लस s² by 2 f2, ये इवन फंक्शन है, प्लस हाफ s जो बचेगा वो वाला आपका ऑड हो जाएगा, तो 0 हो जाएगा. तो ये वाला पूरा का पूरा इंटीग्रेशन आपका यहाँ से निकल के आएगा इंटीग्रल ds। ओके, और इस इंटीग्रल का वैल्यू अगर आप जब निकालोगे तो आई थिंक बहुत आसानी से निकल के आ जाना चाहिए। 2h यहाँ पे रख लेते हैं और देख लेते हैं, एस स्क्वायर का एस क्यूब बाई 3 हो जाएगा। तो पहला जो आएगा वो एस क्यूब बाई 3 2 जा 6 हो जाएगा f0 माइनस एस क्यूब बाई 3 f1 प्लस sf1 प्लस एस क्यूब बाई 6 f2। और ये सारी वैल्यूज कहाँ से कहाँ तक है, 0 से 1 के बीच में है। जब s इज इक्वल टू 0 रख दोगे तो सब कुछ तो 0 हो जाएगा, s इज प्रेजेंट एवरीवेयर, तो आपको केवल 1 वाली वैल्यूज मिलेंगी। तो 1/3 देखोगे तो कॉमन, इनफैक्ट हाँ 1/3 क्या 1/6 कॉमन कर लो तो 2 भी कैंसिल हो जाएगा। तो हमें मिल जाएगा h/3, बिकॉज इवेंचुअली हमने h/3 में फॉर्मूला रखा हुआ है। तो h/3 6 यहाँ से कॉमन हुआ, 1 क्यूब पहले मिला तो f0 हो जाएगा माइनस 1/3 आप 1/6 कॉमन किया ना, तो यहाँ पे 2 मिलेगा माइनस 2f1, और यहाँ पे क्या मिलेगा माइनस 2f1 प्लस, क्योंकि आपने 1/6 कॉमन किया था यहाँ पे, तो 6f1 मिल जाएगा यहाँ पे 6f1, 1/6 यहाँ पर भी कॉमन किया हुआ था तो प्लस f2। तो इवेंचुअली देखोगे तो यही वाला आपका फॉर्मूला मिल गया। ठीक है, हाउ डिड यू गेट द वैल्यू ऑफ s? बहुत सिंपल है, s का फॉर्मूला कहां से आया आपके पास में, s तो आपने ट्रांसफॉर्मेशन किया है ना, s इज इक्वल टू x माइनस x1 अपॉन h। जब x की वैल्यू, अगर यही तो रिलेशन है ना दोनों के बीच में, s और x के बीच में क्या रिलेशन है कि s इज इक्वल टू x माइनस x1 अपॉन h। तो अगर x की वैल्यू x0 है तो s की वैल्यू क्या होगी, x0 माइनस x1 अपॉन h। x is equals to x0 implies that s is equal to x0 minus x1 upon h। x0 minus x1 कितना है, माइनस h है, तो ये माइनस h बाई h आपका -1 हो जाएगा। उसी तरह जब x की वैल्यू आपकी x2 है तो x2 माइनस x1 हो जाएगा, x2 माइनस x1 की वैल्यू कितनी है, प्लस h है, तो x2 माइनस x1 प्लस h बाई h हो जाएगा। ठीक है, सो आई थिंक कि आपको काफी कुछ समझ में आ गया होगा सिम्पसन्स 1/3 कैसे निकालते हैं। ठीक है, तो this is what I think I will stop. This is where I will stop today. Or I think I can do one more example. Let me see. So we can probably do one more example, and then maybe then we will stop. So let us do one more example. This will probably help you. If you have calculator, you take the calculator out, and if you don't have, then use the mobile. There also scientific calculator is given. So suppose we have to find 0 to 2 pi by 4 x raised to power 4 cos pi x by 4 dx। सपोज हमें इसका इंटीग्रल निकालना है, तो यहाँ पे fx की वैल्यू क्या हो जाएगी, ये आपकी fx की वैल्यू हो गई। ठीक है ना, so here a is equals to 0, b is equals to 2, और fx वैल्यू क्या हो गया, pi by 4 x raised to power 4 cos pi x by 4। ओके, सो फर्स्ट थिंग फर्स्ट, मैं बहुत सिंपल वाला फॉर्म करने जा रहा हूं। सो हमें सिम्पसन्स 1/3 लगाना है। ठीक है ना, सो सिम्पसन्स 1/3 का मैंने पहले क्या नियम बताया, सबसे पहले कि n हमारा इवन होना चाहिए। तो मैं क्या कर रहा हूं, शुरुआत में बहुत इजी रख रहा हूं, मैं n को 2 ही सिलेक्ट कर रहा हूं। ठीक है ना, तो आई एम चूजिंग n इज इक्वल्स टू 2। इफ n इज इक्वल्स टू 2 देन h इज इक्वल्स टू b माइनस a डिवाइडेड बाई n। तो h आपका कितना हो जाएगा, 1 हो जाएगा। xj इज इक्वल्स टू क्या होता है, 0 प्लस jh, जहां पे j की वैल्यू क्या होती है रूल के हिसाब से 0 से और n के बीच में, n यहाँ पे 2 है, तो इसका मतलब आपका x0 इज इक्वल्स टू 0, x1 इज इक्वल्स टू 1 और x2 इज इक्वल्स टू 2। jh से आपको यही वैल्यूज मिलेंगी, h इज इक्वल्स टू 1 है और j आपका 0 से 2 के बीच में है, तो ये आपकी वैल्यूज मिल गई x0 x1 x2। अब करस्पॉन्डिंग टू दीज x0 x1 एंड x2 आपको वैल्यू निकालनी है f0 की। f0 मतलब f एट x0 या f एट x0 भी आपका 0 है। तो उसकी वैल्यू जैसे ही आप x की वैल्यू 0 रखोगे वो आपकी 0 हो जाएगी। ठीक है, f at x1, वो जो f1 है, f1 है, f at x1 है, f at x1 जो है आपका जो वैल्यू है fx1 that will be pi by 4 1 raised to power 4 cos pi by 4। ठीक है, cos pi by 4 का वैल्यू 1 by रूट 2 होता है, सभी को पता होगा। ठीक है, तो इसका वैल्यू हो जाएगा पाई बाई 4 रूट 2। और f2 का वैल्यू f at x2, अब इसको कैलकुलेटर से आप निकाल सकते हो, पाई बाई 4 रूट 2 का वैल्यू। f at x2 कितना हो जाएगा, x की जगह पे आपको रखना है अब 2। ओके, तो जैसे आप 2 वैल्यू रखोगे यहाँ पे cos पाई बाई 2 हो जाएगा। cos पाई बाई 2 का वैल्यू 0 होता है, सभी को पता होगा। ठीक है, तो सिम्पसन्स 1/3 से ये वाला देखो, इसमें कैलकुलेटर भी ज्यादा यूज नहीं होगा। सिम्पसन्स 1/3 से fx dx, जहां पे fx का वैल्यू ऊपर दिया हुआ है, वो क्या हो जाएगा h/3, h इज 1, h/3 f0 प्लस 4f1 प्लस f2, उसका वैल्यू निकालोगे तो 1/3 f0 इज 0 प्लस 4f1 पाई बाई 4 रूट 2 प्लस f3 का वैल्यू 0 करोगे। फाइनली जब कैलकुलेट करोगे तो देखोगे, सॉरी 4 भी आएगा यहाँ पे, 4 यहाँ पे आएगा, 4f1 है ना, 4f1। सो फाइनली जब कैलकुलेट करोगे तो ये आ जाएगा पाई बाई रूट 2, जिसका वैल्यू जब आप कैलकुलेट करोगे तो 0.7404 आना चाहिए रफली। देखो इसी के आसपास कुछ वैल्यू आएगी। ठीक है, नाउ सपोज इफ आई मेक इट लिटिल मोर कॉम्प्लिकेटेड, थोड़ा टेडियस कर देते हैं, एंड इंस्टेड ऑफ 2 पॉइंट्स आई इंक्रीज द पॉइंट्स। ओके, आप चाहो तो आप और भी पॉइंट्स ले सकते हो, एंड बट आई विल बी चूजिंग ओनली 4 पॉइंट्स नाउ। So consider as case 2. So n is equals to 4 now. As I told you, हमेशा हमको क्या चूज करना है सिम्पसन्स 1/3 में, इवन ही चूज करना है। तो h बदल जाएगा, अब h इज इक्वल टू कितना हो जाएगा, 2 माइनस 0/4, 0.5 हो जाएगा। ठीक है ना, और xj आपके बदल जाएंगे, xj इज इक्वल टू क्या हो जाएगा, jh हो जाएंगे वो सारे। ठीक है ना, सो इनका वैल्यूज आपका बदल जाएगा। तो टोटल 5 पॉइंट्स आपके मिलेंगे, जिसमें लेट अस से xj यहाँ पे कर दिए हमने और fj यहाँ पे कर दिए। पहला 0 मिलेगा, 0.5 1 1.5 2, दिस 5 xj's you will get। f0 तो आपका 0 हो जाएगा, है ना। f0.5 का वैल्यू अब आपको कैलकुलेटर से निकालना पड़ेगा, 0.045351। ओके, ये वैल्यू निकल के आएगा। जब f1 का वैल्यू निकालोगे तो आएगा 0.55536। जब f1.5 का वैल्यू निकाल के रखोगे तो ये बन जाएगा 1 पॉइंट, एक मिनट यहाँ पे इसका कुछ गड़बड़ है, f0 ठीक है, शायद एक बार चेक कर लेना, जस्ट चेक दिस वैल्यूज वंस। सो 1.521579, आई थिंक एवरीथिंग इज करेक्ट। और f2 का जब वैल्यू निकालोगे तो वो 0 आ जाएगा। ठीक है ना, तो ये आपके वैल्यूज हो गए f0, f1, f2, f3 और f4। when you will put all these values in the formula, then 0 to 2 fx dx, finally you will put the values 1, h is 0.5 now, 0.5 by 3, f0 is 0 plus 4 times f1 plus f3, f1 is here, f3 is here, this value of f1 plus f3 you substitute, plus 2 times f2 you substitute, plus f4 you substitute all these values, and then you should get 1.22974। ओके, एक बहुत ही इंपॉर्टेंट नोट है यहाँ पे, पहले कुछ लोग कर लीजिए, देखिए वैल्यूज मेरे साथ मैच कर रही हैं या नहीं मैच कर रही हैं. Just have a look at the values, if whether they are matching or not matching. 36 55536. Five. F2 समझ में नहीं आया. $7.53. Are you able to get this one or not? There are so many comments, I can't follow all the comments. Couple of you have pointed that you have got the correct answer. So here one thing is very important. Yes, perfect. So here one thing is very important. You are evaluating the cosine function. If you have noticed here, you are evaluating the cosine function. Okay. Whenever you are evaluating the cos x, please do remember this one, cos x, sin x, this function. When you are evaluating cos x, then x is always in radian and not in degree. Not in degree. So in calculator, you have to set x as radian and then only you can calculate the value. So say for example, if you are evaluating the cos 1.5, then the 1.5 value should be input as radian. Okay. Then this is what the correct value the calculator will give if you input the value in radian. Okay. So if you are finding out the cos of 1.5, your calculator should give you the value as 0.0707. 0.0707. This is the correct value which it should give you when you are calculating cosine value as radian. Okay. Whereas if your calculator is at the default setting, it will give you the wrong value as 0. If you put in the degree cos of 1.5, because it will be very close to 0, so it will give you approximately 0.999. You can check your calculator, and if you don't put the radian, then it will give you 0.999, and it's cos 1.5. And that is caution. Okay, this is very important caution which you should remember when you are evaluating the value of cosine x. X must be in radian and not in degree. Okay, so it should not be considered in degree, not in degree. So this is correct value. Okay, when you are evaluating, this is correct value. This is correct value. Any other value which you are calculating, or anyhow you are calculating, this is during the programming also. So this is your correct value, other values might be wrong value. So this you have to take care, okay, during the calculations. Okay, so if there are no more questions, then maybe I can stop here, and we'll meet for the next week. I'm stopping the recording now because I have stopped the teaching. Please wait.